All right, y'all. What is the z-score of the 35th percentile? Whew. I feel like I don't know how to do this without at least like drawing a picture of seeing what this even means. Yeah? So let's think this through. Can somebody remind me what a percentile is? What does it mean if I say my height is the 35th percentile, besides being overly optimistic about my height?
You're 15% shorter than most.
Hold.
You're 65% shorter.
I am shorter than 65% of people.
Yeah.
Another way of saying that is
You're taller than
my height is bigger than 35% of people. Again, incredibly optimistic, I know. Okay? But hold on. How would that apply to the normal distribution?
Oh, okay, well, I was thinking about that.
Because that percent of people... So could we draw a line on our normal curve where the 35th percentile would be approximately? Would it be on the left or to the right? We're good with that? Okay, so let's see. I'm going to just tell me when to stop, where you think I've hit about 35%. Right there? Nah? Nah?
Stop.
We all feel decent?
A little less, maybe.
I think maybe a little less. Right here?
Yeah.
Is this okay?
Well, nice.
How about right there?
Yeah.
Give or take? I appreciate you being willing to take the risk of answering, Mario. Can you tell me how you made that decision? Like, when I say 35%, 35% of what?
100.
100? The whole graph. And what about the area of that graph? Yeah? Okay, so when we talk about that percentage, what we're saying is I don't know the boundary, but I know that this area is 35% of it. So, thinking through the process we've been doing with our upper and our lower, well, I guess I know my lower is negative a gajillion. Do I know my upper? No, in fact, I know the area instead, so I have to work backwards. You guys, does anybody remember the mathematics word for backwards operations? What do we call them? Inverse operations, yeah? So let's go back into that menu real quick. If I go into second vars and I do this one more time, do I see anything that might help me work backwards or do the inverse operation for the normal curve? You guys see, I'm not trying to talk like you're 5-year-olds, but it is built with there's a process behind how the calculator is built. So if I choose that inverse norm, it asks me for an area. And then it says left, center, and right. Does anybody's calculator not say left, center, right? Perfect. Okay, so what I need to tell it is that I know that my left-hand area is 0.35 if I hit enter. Now, no, before I hit this, you guys, it's going to give me this number. Can somebody tell me what we know about this number? Anything.
Less than 0.
It's going to be less than 0. Is it okay to get a negative here? Sure. Because all that negative tells me is I'm finding a boundary that is below the mean. Is everybody good? So I go ahead and I hit enter. I find that z-score is negative 0.385. Now, big picture, what I need you guys to get from that is that for any normal distribution, in order to be the 35th percentile, that person, whoever that is also 0.385 standard deviations below the mean. Everybody good? So we talked about percentile and z-score as measures of position, they're describing where things are, it makes sense that someone below the mean would have a negative z-score. 35th percentile is not super low, so not a lot of standard deviations below the mean. We feeling okay? Cool. This is a good stopping point. We'll start up with these two examples tomorrow. Now I think we're ready. Okay, y'all. Like I said, I don't think today will go the whole time. You'll have some time to start working through your homework packet. There are 2 Unit 6 labs on Monday and Tuesday. We're going to do Lab 6A. Wednesday and Thursday, maybe we'll finish the notes. I'm going to hope that we can get them done on Wednesday. That'll be a push to get them done on Wednesday, but I'm going to try. And then Thursday, Friday, finish up Unit 6. Okay? I will say that the labs, the 2 Unit 6 labs will take up a lot of class time next week. I would recommend you get as far in the homework over the weekend as you can. Okay? All right, so we were talking about normal curves yesterday. So if I asked you to draw a picture of what z-score correlates with the upper 5% of the curve, the first thing we would want to do is draw the normal curve and shade the upper 5%. So if I'm doing that, if it's z-scores, what do I know about my mean? What's the mean of the z-scores? 0. What's the standard deviation?
1.
And so if I were to do the upper 5%, I'm going to shade from the right, because that's where the upper values are, right? And I'm going to do approximately 5%. It's not going to be, I won't be actually measuring if it's exactly 5%, y'all, okay? I don't even know how I would. All right, and then I want you to go ahead and label that area. Now, I think everybody in here's calculators, or you either use mine. I don't see anybody that doesn't have the left, center, right. So when you go to put this in your calculator, and what I'm going to say, guys, is going to go for go for people who don't have this as well, okay? Because of the morning class. So you're going to go into your distributions menu, so second vars. This is the one where we would choose inverse norm, because what we know is the area. All right, and so Ms. Meister was raised in a stats world where the calculators didn't have left, center, right. And so originally, in the older calculators, all only think in left side areas. So there's kind of 2 options if you have a calculator that says left, center, and right on it. Okay, I'm always going to do the left because that's what it's basically how I was trained to do statistics, because back in the day, the calculators were a lot older and less fancy. Okay, so left, you can either say the area is 0.05 and highlight right, and we see 1.645. Okay, if your calculator doesn't say left, center, or right, and then what you can do is put in 0.95, which is the left side area, and highlight up. We're going to get the same answer. Okay. For those of you watching this video, if your calculator doesn't give you left, center, or right, your calculator automatically thinks left, so you need to give it the 0.95, because that's that left side area, okay? Either way, we are finding that the z-score is equal to 1.645. All right, now, what z-score correlates with the middle 85% of the curve. If I sketch that curve, center 0. It is going to be important to me, again, that you always draw the picture, mean, standard deviation. The middle 85%, if I sketch out kind of where that might be. Okay. Now, if I'm doing this one and I'm trying to decide, well, what is the area in the tails? If I've got 85% of the values inside, how many do I have outside? Combined. What is the percentage in the 2 tails? 0.15. So what does that make each tail? 0.075. Now, you guys, I know that you guys can just pick center. There will be something that we use very, very similar reasoning that doesn't give you the option of left, center, right. So we all need to understand how this 0.075 is actually one of the areas that we're finding, okay? Because later on we're going to use something very similar to this, but not this, where you have to be able to understand that we want the left side area. In fact, if I were sitting in your position, I would always just keep the left highlighted and think through left, left, left. Okay? Either way, when I go to put it in, what I found is that this value right here is negative 1.440. What does that make this one? Because there's two boundaries here, right? What's the other boundary? Positive 1.440. You don't need to do it twice. And if you choose center, it'll give you both of them. Good so far? Now, let's move on to what happens when. All right. What happens when I'm not talking about z-scores and I'm talking about actual real-world problems, okay? So we have that the weights of cows are normally distributed with a mean of 600 and a standard deviation of 45. Okay, what would be unusual? Can somebody remind me, how do we figure out what is unusual? The mean plus or minus 2 standard deviations. So can you guys tell me what are the boundaries of the mean plus or minus 2 standard deviations? So if I ask you what is unusual, I might expect you to say less than 510 pounds, more than 690 pounds. Now, I graded your homeworks. There's a lot of people who put yes, no, with zero justification whatsoever. That's not going to go well for you, okay? On any point, I should be able to see some sort of mathematical reasoning. If you're just writing answers, I was actually pretty generous because I didn't take off all the points if you wrote an answer and got it wrong. Unless it was really, really wrong. But next time, on the test, if you get something wrong with no work, no justification of what and you're just writing decimal answers, and you get it wrong, it'll be you lose all the points. Because I've got no evidence that you are showing me you know what you're supposed to know. Does everybody understand what I'm saying there? Your grade is going to represent that you show me what you need to know. Likewise, if you just give me a decimal and you're not showing me your thinking, you're not showing me everything I need to see. Okay? I at least need probability statements plus the decimal. What probability are you even finding? Okay? So some of you are going to be kind of disappointed that I marked things wrong in your homework, but the idea is you need to show support to of your answers in some capacity. Okay? Now, all right, let's say we're doing this problem. Find the probability that a cow weighs less than 675 pounds. If I draw this picture, I'm not talking about the z-score being 675 pounds. I'm talking about the actual weight of the cow. What is the mean of the cows? 600. What is my standard deviation? 45. I want to see those two things labeled. But because now I'm not comparing that cow to its z-score. I'm comparing it to the actual values. All right, 675 would be about here. I'm going to shade it to the right. And now my probability statement is going to be the probability that X is bigger than 675. not Z because it's not a Z-score. It's the actual weight of the cow. In this case, what we have are the boundaries. That's when I choose normal CDF. What is the lower boundary of what I've shaded? 675. My upper is going to be some really big number. My mean is 600. My standard deviation is 45. .048. Anybody need help with the calculator? How much would the 40th percentile weigh? Label your mean. Label your standard deviation. You guys, tell me where to stop if I'm going to be at the 40th percentile.
Stop.
Seems pretty good, pretty close. You think I should go a little bit further, don't you?
No, go out, right? Because that's 50.
This is 50. Yeah,
Yeah.
I'd put it like right about there. Because it's very tall.
Oh, yeah.
Remember, the tallest section is right there, right? Either way, do you have to be perfect? Of course not. Because you know how you're going to tell me that you know that this is 40%? You're going to label it as 40%. And we're trying to find that value. Okay, so I need to work backwards. So I'm going to choose on my calculator that inverse norm. When I choose inverse norm, it asks me for the area. What area should I give it? Well, I know that my left-hand area is 0.4. Put my mean at 600. I put my standard deviation at 45. I get x equals 588.6. Which happens to be the 40th percentile. You feeling okay? Guys, try part A. So yes, it should have been less than. But, well, yeah, that's not. Questions? How do we feel about part A? Draw the picture for part B. You can check your picture against mine. And then I got 0.581. How are we feeling with the calculator right now?
How do you find that area?
For this one,
Yeah. Do you just like
you use normal CDF.
Oh,
Right. So your calculator is either going to ask you for boundaries, or it's going to ask you for the area. So did you pick inverse norm?
yeah.
So if it's asking you for something you don't have, that's just your cue that like, oh, I picked the wrong one. Go back. What I have are the boundaries. I want to pick normal CDF. But there's only two options, y'all. So if it's asking you for what you don't have, go back and pick the other one. You with me?
Yeah.
Okay. How are we feeling about getting to here? All right, lastly, how tall is Q3? What do we know about Q3? Well, as we do these, y'all, everything we have are either boundaries or percentages. So is there a percentage that we can associate with the third quartile? 75% to the left of it. Okay? Like Q3, asking that is like basically saying P75. Those are the same thing. Okay? So I would look at this and I go, okay, here is Q3. If that's Q3, this area is 0.75. So now what I gave you was the area, so I'm going to pick inverse norm because that's the one that I input an area. Something different?
Yeah.
Double check that you use 52 as your mean and 4.3 as your standard deviation. All right, I got two more at the bottom for you guys to try on your own. I'll put the answers up in just a second. And then the rest of the time you can work on homework. If you guys want to check your answers.
The last one would be
CDF, you'll never use the PDF. What the PDF would tell you is that you're exactly 3.1, which you're not, like you never are. Like it's never exactly, we'll never, ever, ever use the PDF when it's normal. We'll use it for binomials, we'll use it for Poisson. We wouldn't use the PDF for normals. Because keeping in mind, PDF is exactly, right? And we're always going to be doing less than or greater than or some range of values. Do we have any questions? In terms of the Unit 6 homework, guys, you guys should be able to do like numbers 1 through 7 right now. In terms of, if you try, it might feel like you can do some of the problems after that, and you can't. Until we go through what we have to learn next week, okay?